So here's a quote from Linus Pauling. "I feel sorry for people who don't know anything about chemistry. They are missing an important source of happiness." Can you tell he was a chemist? So this chapter is about chemical reactions and chemical quantities. The author uses combustion and the production of CO2 as an example, and so I'm going to talk about the greenhouse effect and global warming just a little bit. I'm not going to test you on the greenhouse effect because that's not really chemistry, but I think it's good for all of us to have a basic understanding of how does our planet stay warm. So a greenhouse allows plants to grow when the outside temperature is too cold, because it's got glass and the sun comes through the glass and it warms up the air inside, and then because it's enclosed in glass, the warm air can't just blow away, right? And so the inside the greenhouse is warmer. So there's a layer of gases in our atmosphere that act like a greenhouse. And so they allow the sunlight to pass through, which warms the Earth's surface, but then they reflect some of the radiant heat and keep it inside. And so this atmosphere keeps our planet from being too cold. But you also have a balance, of course, as with like everything in life, right? There's a balance. So if you have too many greenhouse gases, too thick of a layer, then you're going to get too warm. If you don't have enough, you're going to get too cold. And that temperature range that is good is actually very, very narrow. So one of those greenhouse gases is carbon dioxide. Here's a graph showing atmospheric carbon dioxide levels from before 1860 through, I think, like 2016 or something. They went from below 290 parts per million to above 400. So that's a rise of 38%, which is a significant rise. And if we look at average global temperatures over that same time period, we see that there is also a rise, and they seem to be roughly the same shape as the rise here. This looks very alarming, but it's important to note the temperature range here. So this is change in temperature. So if this is the baseline, here it was below that, and here it's above that by 1 degree Celsius. So it's not a huge change, right? It's 0.7 degree rise. Now, something that small can be significant, right? And if you listen to the news at all, there are a lot of people that are extremely concerned about the future of our planet. But the thing that a scientist looks at is 0.7 degree change in terms of the uncertainty of that measurement. Is that really significant? That's what I'm curious about. And then the other thing is there are long cycles, like hundreds, thousands of year cycles, where the average temperature goes up and down naturally. And so the question here is, are these two trends causal? And mostly people ask, is this increase in carbon dioxide causing the increase in global temperature? That's an excellent question. Personally, I feel that the evidence is not compelling either way. I have not taken the time to examine all of it, but what I've heard on both sides, it's like, I don't know. So I'm kind of on the fence. Does that mean we shouldn't take care of the planet? We shouldn't try to reduce our CO2 emissions? No, of course we should, right? But should we sacrifice our economy to do so? I don't think so. So I think we should take reasonable precautions to try to limit our impact on the Earth. But a 0.7 degree increase here, I think, is not something that we have to freak out about. So where's this CO2 coming from? Well, one source, of course, is the combustion of fossil fuels. So most of us probably drove gasoline burning engines, cars to campus today, right? Well, the combustion of gasoline gives off CO2. Another source of CO2 is volcanic action, which is normal. We have no control over that. So how can we see whether this increase in CO2 is due to human activity, combustion of fossil fuels, or due to natural causes such as volcanic action? Well, we'd have to have some way of estimating how much of the CO2 came from combustion of fossil fuels. And so we can estimate these sorts of things by looking at the chemical reaction that occurs when gasoline and other fossil fuels burn. We can estimate the amount of fossil fuels that have burned. I don't know exactly how they do that, but they know how much oil was sold, etc. And so we could calculate, if we understand the chemical equation, we could calculate the amount of CO2 that was released from burning that amount of fossil fuels.